In this question, we have to find out whether this number is divisible by all the numbers listed. So let's go through them and see how it goes. Divisible by 2. The number is even, so we automatically know that it is divisible by 2. What about 3? Let's use the rules that are in our notes. So to find out if a number is divisible by 3, we add all the digits together. 1 plus 3 plus 7 plus 4 plus 4 plus 5. I don't have to write plus 0. That's equal to 24, which is divisible by 3. Great. What about 4? The last two digits have to be divisible by 4. 50 is not divisible by 4, so this number is not divisible by 4. 5. The last two digits have to be 0 or 5, and it is 0, so we are good. It is divisible by 5. What about 6? For a number to be divisible by 6, it has to be divisible by 2 and 3, and we have already proven that it is divisible by 2 and 3, so we know that it is also divisible by 6. I'm just going to copy this number over so we can see it as we scroll down. 1,450,000. Okay. So next we have 7. So we have to remove the last digit and subtract twice that digit from what's left over, and we have to do this repeatedly until we find a number and can determine whether it's divisible by 7. So we're going to remove the last digit here, which is 0, and subtract twice that digit from what is remaining. Twice 0 is just 0. So I'm going to rewrite this number without that 0, just like that. And so we have to repeat that process until we get something that we can work with. So now I'm going to remove the 5, and I'm going to subtract twice 5 from the rest. So twice 5 is 10. So my new number is going to be 34. Okay, I'm going to repeat this one more time. Here's my last digit. It's 4. Twice 4 is 8, so I'm going to subtract 8 from 1,373, which will give me 1,365. The last digit is 5. Twice 5 is 10, so 136 minus 10 is 126. Once again, I'm going to get rid of the 6 and subtract twice 6, which is 12, and 12 minus 12 is 0. I have a remainder of 0, so my number is divisible by 7. Let's try 8. If the number is divisible by 8, it has to be divisible by 2 and 4. But I proved that it is not divisible by 4, so it can't be divisible by 8 either. What about 9? 9 works the same as 3, so let's add all the digits together. We already did that up here. And we got 24. 24 is not divisible by 9. What about 10? If a number is divisible by 10, it ends with a 0, and this one does, so we are good. What about 11? This one's a little bit trickier. What is the rule? It's the alternating sum. So it's like calculating the divisibility for 3 and 9, except instead of adding everything together, we alternate the signs. So I'm going to write positive 1, and then I'll write minus 3 plus 7 minus 4 plus 4 minus 5, and I don't have to write plus 0. So minus 4 and plus 4 will cancel out. I'm left with 1, minus 3 is negative 2, plus 7 is 5, minus 5 is 0. The remainder is 0, so this number is indeed divisible by 11. I wrote 12, but I meant 11. Sorry about that. Okay, now we're moving on to 12. So for the number to be divisible by 12, it has to be divisible by 2, 3, 4, and 6. Well, I know it's divisible by 2, 3, and 6, but it's not divisible by 4, so it can't be divisible by 12 either.